Hello everybody. In this video, let us understand how we can express this simple square wave in terms of sine and cosine functions using Fourier series. According to Fourier series, we can express any function f of t as a naught plus sum of a cos t plus sum of b cos t. The derivation of Fourier series is beyond the scope of this video. Let us say y is equal to function of t and the graph we see has time t on the x-axis. Now we know that to express the given simple graph in sine and cosine form, we just need to find the values of a0, an and bn. So here's the formula. a0 is equal to 1 by 2 pi integration of f of t dt from 0 to 2 pi, where one wavelength is assumed to be 2 pi. Similarly, an is equal to 1 by pi integration of f of t cos nt dt from 0 to 2 pi, and bn is equal to 1 by pi integration of f of t sin nt dt from 0 to 2 pi. Let us find a0 first. We can break the integration part from 0 to 2 pi to 0 to pi and then pi to 2 pi and integrate separately over these two intervals. In the graph, we see that from 0 to 1, y is equal to 3. Let us assume the graph to have pi interval on its x-axis. So from 0 to pi, y is 3, and from pi to 2 pi, that is from 1 to 2, on the graph y is equal to 0. Hence a0 is equal to 1 by 2 pi 3t from 0 to pi, that is equal to 3 by 2. Now let us find an. Again we break 0 to 2 pi interval into 2. Integration of cos nt becomes sin nt divided by n, and for both the intervals sin will become 0. Hence an is equal to 0. Moving on, let us check for value of bn. We break the integration interval into two. First one from 0 to pi and the other from pi to 2 pi. We do this because we know that value of function of t from pi to 2 pi is equal to 0. So we can easily get rid of that part of integration. Hence bn becomes 1 by n pi multiplied by 3 into minus cos n pi plus 1. Due to this, we have two cases when n is even and when n is odd. Suppose n is even, say 2, then bn would become 3 by 2 pi multiplied by minus cos 2 pi plus 1. We know that cos of even pi, that is 2 pi, 4 pi and so on, will always be equal to 1. And finally, minus 1 plus 1 would always become 0. And hence, when n is even, bn is always equal to 0. Now take n to be odd, say 1. Hence, bn is equal to 3 by pi multiplied by negative cos of pi plus 1. We know that cos of odd multiple of pi, that is 3 pi, 5 pi, 7 pi and so on, will always become equal to minus 1. So bn as a result would always become 3 by n pi multiplied by 2, that is 6 by n pi. Hence we conclude that value of b will only exist when n is an odd number. So we have our Fourier expression ready, that is as shown. If we plot its graph, we find something very similar to our original graph. This graph becomes more and more similar to the initial square wave as we go on increasing the number of terms for the Fourier expression. Thank you.